Hello everyone. In this lesson, we're going to learn about averages and weighted arithmetic mean. First of all, what is average? Average is a single value that represents the whole set of values. Let's say we have 8 students in a class and their midterm marks are given here. So we have a data here which consists of different values, right? 97, 85, 68. So we have a whole set of values here. We want to see the performance of this class as compared to other classes. So we are looking for a single number which can represent the whole set of data here. So that single representative is calculated using average. So average will help us to calculate the single representing value of this data, right? There are different kinds of averages, mean, median, and mode, but here we'll just talk about the very commonly used average, which is arithmetic mean, or it is sometimes called as arithmetic average. Now, arithmetic average is you add all the values, individual values in the data, and then divide by total number of observations, right? Another method is add the values and then divide by the total number of observations. So if we consider this data here, arithmetic average or arithmetic mean would be sum of all the values. So we're going to add individual values 97 plus 85 plus 68 plus 52 and so on. You can just represent other values with dots and then you can close it with the last value. So this represents the set of all the values. This shows the number of observations and now divide it by total number of observations. How many in total you have? 8 observations because you are recording the marks of 8 students. So you'll divide it by 8, right? And this comes out to be 630 divided by 8, right? When you calculate 630 by 8 using the calculator, it comes out to be 78.75, right? So this 78.75 is the central value of this data, or you can say the central tendency of the data of scores of 8 students is 78.75. If you have another 8 students of different class, you can calculate their arithmetic mean, right? You have another set of data and you calculate their arithmetic mean, then you can compare the performance of these two classes with single representative, right? So this is arithmetic mean of the first data, and then you calculate the arithmetic mean of second data, and then you can compare which one is better. Here I have considered two examples. My first example is average of first 5 prime numbers. So we need to calculate the average of first 5 prime numbers. First of all, let's write down the prime numbers. Now, what are prime numbers? Prime numbers are the numbers which are not divisible by any other number but one and number itself, right? We did this in last lesson. Now let's write down the first 5 prime numbers. My prime numbers are 2, 3, 5, 7 and 11, right? So these are my first 5 prime numbers. When you add them together, you get 28, right? This is the sum total of first 5 prime numbers. Now average. Average formula is you divide the total or the sum by total number of observations, which is 5 in this case. So total comes out to be 28 divided by 5, and you get 5.6, right? So that 5.6 is the middle value of first 5 prime numbers. And that makes sense. Your data, the lowest value is 2 and the highest value is 11, right? Now 5.6 being the middle value lies somewhere between 2 and 11. That is your checkpoint. Your average should always be somewhere between the highest value and the lowest value, right? Okay, next example is the average of 6 numbers is 50. If 5 numbers are 57, 60, 45, 48 and 65, we need to find the sixth number, right? So here average is already given. We need to calculate one of the number. Let's find the total here. When average is given, you can calculate the total. Total is average times the number, right? Which is n. So average is 50 here. 50 times, because we have 6 numbers, so the total of 6 numbers is 300. How do we calculate the total of numbers? So we add them together. So when we calculate the total of 5 numbers, just add the given numbers. So 57 plus 60 plus 45 plus 48 plus 65. When you add them together, you get 275, right? This is total of 5 numbers and this is total of 6 numbers. What will be the sixth number? So you subtract, right? So your sixth number is, just subtract the totals. So 300 minus 275, and this comes out to be 25. So your sixth number is 25. Next is the average of 4 numbers is 9. The average of another 3 numbers is 16. Find the average of numbers. Average of 7 numbers. Okay. Again, the average is given. Average of 4 numbers is 9. Let's use the information bit by bit. Now, when the average of 4 numbers is 9, what is the total of 4 numbers? Total of 4 numbers is 4 times 9, right? That is 36. Now, next information is average of another 3 numbers is 16. Now, let's calculate the total of next 3 numbers. Total of 3 numbers is 3 times the average, which is 16, and this comes out to be 48, right? Now we want to calculate the total of 7 numbers. Total of 7 numbers. This is 36 plus 48. 36 plus 48, and this comes out to be 84. So we have total of 7 numbers, which is 84. Now we'll go reverse to calculate the average. So average is total divided by n, right? Now the total is 84 and n is 7 because we have total number of observations now, 4 plus 3. So it is 7. So that comes out to be 12. Next we have weighted average. This is another type of average where each individual value has been given a different weightage. I'll show you with an example. Let's say you have a data set where each individual item is denoted by X and its importance or the weightage assigned to each individual value is W. Let us consider each piece of information. Your first information says the data set is the data value is 4 and the weightage assigned to 4 is 3. Then another piece of information is, let's say it is 2 and the weightage assigned to it is 5. X is 3 and weightage is 2. Now the process to calculate weighted average is, you will calculate the product of W and X. That means you're going to multiply the corresponding values of X and W. Now 4 times 3 is 12. Next multiply 2 and 5. So you get 10. 3 times 2 is 6. Now here you're going to add all these values. So 12 plus 10 plus 6. So you'll do column addition now, right? So it comes out to be 28. That is the sum of Wi xi. As you can see here in the formula, you're going to add all Wi xi. So you get 28 in the numerator. For the denominator, you're going to add all the weightages, right? So weightages, sum of weightages, we'll add this column now, and that comes out to be 10, right? Now the weighted average is 28 goes on the top and divided by sum of all weightages, that is 10. So you get 2.8. So your weighted mean is 2.8 in this case. This is how we calculate weighted average. I'll show you with another. Here we have another example which says Kayla received the following grades on her transcript, and we need to find Kayla's weighted grade point. So these are the 6 different courses Kayla had, and um, each course has been assigned a different weightage. So some courses are 3 credit hours and other courses are 6 credit hours, right? And Kayla got different letter grades in different courses. So this is the data we have, and we want to find the weighted graded point, right? So the weightage to each course is the credit hour, right? So that becomes our W column, and letter grade is X. So we want to calculate W and X. Now, before we calculate W and X, we need to find the value of each letter here. So letter A stands for value 4.0, right? Another letter A is 4.0 again. B is 3.0. C plus is 2.5. Then B is 3.0. And then letter C is 2.0, right? So we're going to multiply W, that is credit hour, with each value of different letters, right? So we get here, when you multiply 3 and 4, you get 12. Then again 3 times 4 gives you 12. Then 9, and then 15, then comes out to be 18, and then again you get 12, right? When you add this column, this particular column, your total comes out to be 78, right? Now that is the total of W and X. Now you need the column of W's as well. So when you add this column, you get 27 here, right? At value of all the credit hours. So this is 27. Now weighted grade point is Wx, the sum total of Wx, and divided by the sum of all the weights, right? That is 20. That is okay. Wait a minute. Okay, so that is summation of W. So sum of all the products of W and X, that is 78, and sum of weights is 27. So that comes out to be 2.888 and 8, right? Now, as you can notice, each letter has considered only one decimal place in the value, right? So here we're gonna round off first digit after decimal. So you get 2.9, right? Because the number here 8 is greater than 5. So this 8 goes up. So your letter grade is 2.9. My next example is your mark for this course is made up of 3-term tests, and each test has different weightage: 15%, 40%, and 45%. If your score is 90%, 82%, and 75% on these three tests, what is your average in the course? Now, the weightages of each courses, they become W column, right? So we'll have W column here. Then for X, we'll have scores, right? So that is X. And then next column would be the product of W and X, right? Now here each value is in percentage. So we can calculate the percentages into decimals as we learned in the last lesson. So 15% is 15 upon 100, which is 0.15, right? So same way we can we can convert each percentage into decimal. So we get for the first test 0.15 and X is 0.90. For the second test, 40% weightage, so we have 0.40 and the score is 0.82. For the third test, weightage is 0.45 and the score is 0.75, right? Now, when you multiply them, you get 0.135. 0.40 times 0.82 is 0.328. Next, 0.45 times 0.75 is 0.3375. When you add them together, you get 0.8005. That is the total of WX column. You also need the total of W column, and that comes out to be 1, right? Because it's 100%. The sum total of all the tests will become 100%, right? Now the weighted average score is the sum total, that is 0.8005, and then divided by the sum of all weightages, which is 1. So you get 0.8005. And when you convert this into percentage, because each information given in question is in percentage, so you will convert, multiply by 100, right? So multiplied by 100, you get 80.05. So that's the average score, 80.05%. Okay, now you can pause the video and solve this question. Take 3 to 4 minutes and please come back to see the answer. Welcome back. I hope you got the correct answer. If in case you didn't get the correct answer, please watch the video again. Thank you everyone.